Okay, it's homework time again. So, you know, gathered together my equipment in my little work area. Highlighter, calculator. Might not need that this time. Nothing much you can calculate with sex, really. Ruler, and pencil and pen, and highlighter. So, question number 1. The diagram. Ooh, I love those diagrams. Diagram shows a process that occurs in the testes of male mammals. So I'm already thinking something about making sperm. And making sperm, of course, spermatogenesis. So we're starting off, we've got germinal epithelial cells. So again, you know, annotating your diagram so that you know what you're doing. Mitosis, growth. So mitosis makes spermatogonia. I know. And then we've got growth, and that gives us primary spermatocytes. Then we've got, and it's not telling me anything about divisions, but I'm thinking spermatozoa, they differentiate from spermatids. So this must be secondary spermatocytes, and here I've got meiosis 2, and there I've got meiosis 1. Okay, so name the process. Excellent. So I already had thought, this will be spermatogenesis. Now I can't put gametogenesis, although I suppose that is technically correct, because I've been told it's in the testes of male mammals. Name the equivalent, another name. Name the equivalent process, so the same process that occurs in the ovaries. I'm not even going to highlight female, males don't have them. So the same process but in females is called oogenesis. Name the cell types labelled A, B, C and D. So this is not going to be too tricky because I've already named them, but what is tricky, and it's to make you read the question properly, is that they've put them the opposite way round, so it would be really tempting to write, spermatogonia, but we're not. We're starting with A, and A is there. So you do need to think carefully. So I'm going to start and work my way backwards. So A, spermatids. B, no abbreviations, secondary spermatocytes. C, primary spermatocytes. Can't spell. And D, spermatogonia. Excellent. So, turning over, I recognise that. That's in the booklet. So this again shouldn't be too difficult. So we've got now a cross section through a seminiferous tubule. And again we're starting with germinal epithelium and we're ending with spermatozoa. So effectively, irrespective of what the diagram looks like, we've got 4 gaps in between for these 4 cell types. So spermatozoa differentiate from spermatids. Germinal epithelia to mitosis to give spermatogonia. We've got primary spermatocytes and secondary spermatocytes. And you're thinking, oh, you've not even read the question yet. And I know, bad. But so obvious, there were gaps to be filled in. Use letters A, B and C. Oh, blast. So you see, you should have read the question first. So A, B and C and D. So which was which? Okay, so A were the spermatids. B were the secondary spermatocytes. C, primary spermatocytes. And D, spermatogonia. Well, that'll teach me to read the question, won't it? So, name. The cell labelled X. So here's X. And it's that big long cell that goes from the outside to the inside with all these developing sperm in it. So that's a Sertoli cell. What is the function of that cell? So function, so nutrition. That's awkwardly worded now, isn't it? Nutrition provider for developing sperm. I think if I was in an exam, I might have thought more carefully about how I worded that and provide nutrition for developing sperm. So, cell labelled C. So C, primary spermatocyte, is shown undergoing cell division. The type of cell division. So we're thinking now, is it mitosis or meiosis? So primary spermatocytes, I'll just have a check for where I was thinking about it. Primary spermatocytes do meiosis 1. So this one is doing meiosis. Now it doesn't say to say which division, because that would be a dead giveaway. Ooh, and here we've got a gap. So draw, like a bit of drawing. Draw, labelled, okay. Diagram to show how 2 homologous pairs will be arranged at the equator of cell C at metaphase 1. Well, that was a bit of a giveaway actually, for that I should have put meiosis for cell C. So, metaphase, what am I thinking? I'm thinking they're in the middle. 1, I'm thinking bivalence. How many chromosomes should I draw? 2 homologous pairs. 2 pairs. 2 pairs equals 4 chromosomes. So, what will I need on? I will need a cell membrane. I will need the centrioles because we've got a spindle. Now, I need to think about this because I'm thinking 2 pairs of homologous chromosomes. They'll be in bivalence and they'll be arranged across the equator. So I'm going to be doing something like that. So I'm only going to need 2 spindles, so I'm only going to put 2 on because otherwise the diagram will get very muddled. I'm going to draw a dotted line for the equator and to put my bivalence, one long one, on either side of the equator, joined. So I've got 1 pair, 2 pairs, that's all good. So I need some labels on now. So ruler, it's nice to have ruled lines for your labels. I'll label the equator. What else could I label? I'd have my centromeres. bivalent. What else could I do? Oh, the spindle, obviously. So it's for 3 marks. I don't know what the examiner's got in mind, so I'm just going to label everything that I can. So I've got centriole. And I'm okay to put the centrioles on because of course we're dealing with seminiferous tubules, so we're in animal cells. If it was plant cells, obviously I'd pretty much lose a mark for that. So that's the pole of the cell. I'm going to label the cell membrane because I put it on. I'm going to put that to chromatid. And then I'm going to do another one of these brackety things. And put a chromosome down. Now, so I'm thinking how many labels I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9. It didn't take me very long. I'll almost definitely hit those 3 marks. So, significance. What's the significance of cells like cell C carrying out this type of cell division? So I want the significance, really. This type of cell division, we're talking about meiosis. So really what I think what they're asking me here is what's the significance of meiosis? So produces genetically different haploid gametes. I think that covers it all really. That is it, isn't it? It's genetically different. Don't know whether to say something about fusion and maintenance of to ensure that fertilisation gives varied offspring with the correct chromosome number. And again, I'm thinking, because I'm writing way below the line there, that possibly I've put in a bit more detail than is needed, but I'd rather do that and be sure of hitting the marks.